Dear students, welcome and thank you for tuning in to another Stacks and Dynamics video with me, Dr. Loay Al-Zube. Sometimes in life, an engineer or a student is given the opportunity to design structures and to analyze structures. And this is what we are going to be talking about in this lecture and the videos that are going to follow as part of this lecture. So we are going to discuss chapter 6, which is structural analysis. In this video and the following video, I'll be taking you through a journey in which we're going to learn what is a simple truss, and also we're going through the process of determining the forces in members of simple truss using the method of joints, as well as identifying zero force members. I will be also solving a couple of problems later on in videos that are going to follow this video. Let's start by learning what is a simple truss and why it's important by talking about a couple of applications. Trusses are commonly used to support roofs and buildings. And if you going back in history, human civilization started actually in caves because it's already built structures. Then we use stones to build houses to live in, and then we use concrete. And all of these are actually heavy materials, and it takes a lot of work and effort to build. So trusses actually, in my opinion, is one of the most important structural innovative designs humanity have ever created, because they are actually cheap, and they can be made of light materials, and they can withhold a lot of load based on specific designs. For a given truss geometry and load, we'll have the questions: how can you determine the forces in the truss members to be able to select the sizes of these members? Because this is one of the things that, as a structural engineer or a designer, you need to identify how much force is in the membrane for a given geometry and load, and then you can select if you need to increase the diameter or increase the size of the members of your truss. Also, a more challenging question is that for a given load, how can we design the trusses geometry to minimize the cost? These are the challenges actually that we are facing. We're still talking about the applications. So trusses also used in a variety of structures like cranes, the frames of aircraft, and or space stations. So the applications for trusses are actually limitless, and any structure that is going to be holding or supporting load can be designed using trusses. Also, we will keep asking ourselves, how can we design a lightweight structure satisfying load, safety, cost, specification, and also that's simply manufactured and can allow inspection over its lifetime easily because its parts are exposed. So all of these are actually examples for applications where trusses are used. So whether you are a civil engineer, mechanical engineer, or any field of engineering, understanding trusses and how to analyze the trusses is actually important, regardless of your engineering discipline. And that's why we are covering it in statics and dynamics. We need to make specific presentation and definitions of trusses. So a truss is a structure composed of slender members joined together at their end points. And if you look at the images on your screen, you can see that to your right, that the roof truss, we don't have any loads. These are black arrows in the middle of the member between the end points. So we're going to idealize and assume that when we build a structure, all loads are acting on the joints or the end points where the two members or multiple members are connected together. That's the definition of a truss. And also, if a truss along with the imposed load lies in a single plane, it's a two-dimensional structure as shown on the top right image, then this truss is called planar truss. And we're going to be focusing actually in a couple of videos on analyzing planar trusses. And one more definition is, so a simple truss is a planar truss, so it's two-dimensional truss, which begins with a triangle made of 3 members, right? As you see in your left, bottom left part of the screen. We started with 3 members, that's the triangular element, and then you expand the truss by adding 2 members and a joint. So you can see that we added a DB and DA with a joint at D. So this is a simple truss. And for these trusses, the number of members, M, and the number of joints, J, are related in the equation M equals 2 J minus 3. This is a quick overview of what is the definition of a truss, planar truss, and a simple truss, and how can you identify the number of members and joints if you have a simple truss, starting from a triangular element. I hope this video presents you with the idea and the application of trusses. In the following video, we're going to talk about how to analyze the forces in trusses, and to identify and determine the forces in the members on all the members of a truss using the method of joints. Thank you for watching. Until the next video. Bye.